The lesson outcome for this video is, I can simplify rational expressions after factoring out a GCF. So, in the previous lesson, we talked about how we can cancel things that are in the numerator and the denominator as long as they are common factors. So if you look at this first example, this is similar to the previous lesson. We notice that we have a 2 as a factor in the numerator and a 2 as a factor in the denominator, so we can cancel those out because 2 divided by 2 is 1. So we make 1 or cancel them out. We also can factor out or cancel out any binomial factors that are same in the numerator and the denominator. And so what we see here is we have an x plus 4 binomial factor here and an x plus 4 binomial factor here. At this point, hopefully you'll notice that that is all we can do, and we have x minus 1 in the numerator, either with or without the parentheses is fine. And in the denominator we have an x. That remains. Now remember, you cannot cancel these x's because this x is a term of a binomial factor, and this x is a factor in the denominator. They cannot be canceled. So our final answer is this. And again, even if I had written that as x minus 1 over x without the parentheses, I still cannot cancel these out because x is a binomial, with the negative 1 as a binomial factor. So again, either way to write this answer is fine. You cannot cancel an x out in either situation. Now this next example is the change that we have in this lesson versus the previous, and that is we need to first factor out a GCF, or greatest common factor, before we can do our canceling. Because right now what you see is you have a two-term binomial factor in the numerator as well as in the denominator. Because there is addition in between them, we've got terms. So we can't start canceling things right now. That is a very important thing that you notice right away. So since we have terms, 2 terms in the numerator and 2 terms in the denominator, and we don't have any factors right now, we cannot, or common factors in the top and bottom, we cannot do any canceling. But if we first factor out the GCF of the top and the bottom, the numerator and the denominator, we will be ready to go. So in the numerator, we have a 40 as a coefficient and a 20 as a coefficient. The greatest common factor between 40 and 20 is 20. They both are divisible by 20. Now it's true they're both divisible by 2 as well, but we always want to go with the greatest common factor. They also both have an x in them, in the terms, because x squared is x times x, and there's an x here. So our common factor of x is also going to be taken out. What's left for in the parentheses? Well, we have 40x squared, and we factored out a 20 and an x, so that'll leave us with a 2 here. And then if we factored out from the x squared, we factored out an x, we're left with an x. We have to have this plus sign in our parentheses. And then we think about how we've actually factored out the 20 and the x. But remember, 20 divided by 20, if we're factoring that out, is 1, so we'll need a 1 right there. In the denominator, the greatest common factor is 10 for the coefficients, and again an x. What's left in the parentheses? Well, 10x squared, if I factor out the 10 and an x, I'm left with an x. And in the 30x, if I factor out a 10, I'm left with 3, so plus 3, and we have factored that x out. Okay, so now we are able to cancel any common factors. Hopefully you notice that there's multiplication between 20x and the 2x plus 1 binomial factor, as well as between the 10 and the x plus 3 binomial factor. So we can cancel out the factor of x, and we can also simplify the 20 over 10 by dividing top and bottom by 10, and we get 2 over 1. So our final simplified form for this is 2 times 2x plus 1 over x plus 3. And again, if you have the x plus 3 in parentheses, that's fine, and if it's not, that's fine as well. There's nothing else I can simplify, and that is our final answer. Okay, so we're going to look at a couple more examples. And when I show these examples, the method for my factoring, or just how I'm going to show my work, instead of going off to the side like I did on the previous example, I'm actually going to show how I like to factor this kind of moving upwards and factor this moving downwards, just to keep everything kind of in a fractional form. And kind of to save some space on our work and things like that. So first of all, 2x minus 14, hopefully you notice right away that the greatest common factor between these two terms is 2. Both terms can be divided by 2. So I'm going to factor out a 2, and I'm going to write down in parentheses, of course, what I'm left with. Since 2 divided by 2 is 1, I could write the 1 here, or I could just write the x, either way. And then minus, and at this point I'm doing 14 and factoring out the 2, which is 7. All right. A lot of times what I will do is I will then cross out that binomial that I just used and factored so that I realize I don't have this in my work anymore. I'm just going to use this when I simplify. And then down here I'm going to factor out the GCF, which is an x. I can factor an x out of both terms, and that is it. When I factor an x out of x squared, I'm left with x, and then minus, and when I factor an x out of 7x, I'm left with 7. Again, I'm done with that. Now my numerator and denominator both have a common factor, and that factor is x minus 7. It's a binomial factor that is common in the numerator and in the denominator. So my final answer here is 2 over x, because I have the 2 remaining here and the x remaining here. Why don't you pause the video and try this next one and then check back to see how you did on it. Okay, so the first thing you should have done in this example is factor out the GCF of the numerator. Notice that the 4 and the 3 are not both divisible by the same number, but we do have an x squared and an x to the third. So the greatest number of x's I can take out or factor out of both terms is x squared. So we should have started by factoring out x squared in the numerator, and then say what we're left with here. We're left with a 4. The 4 is still there, and we factored out x squared, so we don't have any more x's with the 4, minus 3, and if I factored out x squared out of the x to the third, I'm left with an x. Okay, in the denominator I can factor out, notice, a 2 and an x, and I'm left with a 1. Notice if I factor out 2 and an x, I am left with 1, because 2 divided by 2 is 1. And then we have minus, and we factor 2 out of the 10, which is 5. And we factor out an x out of this x squared here, so we're left with an x. Okay, now the only thing we can cancel out here, the only common factor there is in the numerator and the denominator, is that this x right here, x squared I should say, can be looked at as x times x, if you want to think about that another way. Therefore, there is a common factor of x in the numerator and in the denominator. So I can cancel out one of these x's here with this x here. And that's all I can factor out. So now, and again I rewrote that x squared, so I rewrote this x squared as x times x, and so I'm not going to look at that in my final answer. So then our final answer is there's an x remaining in the numerator and a 4 minus 3x. And in the denominator I'm left with a 2 and a 1 minus 5x. Nothing else can be canceled out because there's no other common factors. Remember, these x's cannot be canceled because they are part of a term in a binomial factor.